to A, no, yeah, okay, as the sine of little b is equal to, right, so here we saw this angle was given, this angle, no, I don't want to do that. Sine C. Because little a was given, little c was given, and capital C was given. So that would be the one to choose to get started because you're using the information that's given. So then from here, this is equal to A is equal to C sine A divided by the sine C, right? A. Yeah. Okay? So that gives you A. So now we found this guy. And now we need to find C. Well, oh, wait a minute. C was not given. Little c was given. Oh, yeah. And A was given. So we want to solve for C. No, we want to solve. I'm getting confused. I gave you little a, little c. So this guy, and I gave you B. So
you would have to use B.
yeah, so do I?
Well, you need some sort of value in the denominator, right? So
Yeah, I guess you're right. Find one of the other sides. Yeah, so sine of B. Oops. So then B, A is equal to B yes, so we had to use the A. So that gives us A, and then you would use the law of sines to find the other side. So C then would equal the sine of A. A was given, so the sine of A is to capital A as the sine of C is to capital C. So C is equal to A sine C divided by C. So there we have no choice but to use some of the information that was computed given the information that we had. Right? Is that okay with everybody? So for a side, again, assuming the information, the triangle is a valid triangle, there's a unique solution. You start with the law of cosines. You would use the law of cosines twice, and then, or ideally 3 times, but you would use the law of cosines twice, then just add those 2 angles together and subtract it from 180. For angle side angle, we're, again, remember the convention that we're using here is that you got 2 bookends, whatever is in the middle says where that side is or where that angle is. So this side is basically between those two angles. And you would start with the law of sines. I guess you would start with this to find the third angle. And then you would use the law of sines. And that's okay, I suppose, because, you know, the calculation of this third angle can't be wrong. I mean, if you, well, there's calculator illiteracy, but if you can't figure out B correctly, well, there's bigger problems. And then you would use the law of sines to take it from there. So now we got side angle, side angle, side. Here we have side, angle, side. So this is two sides and the angle included, or between them, so. Here we got little a, so that's a over here, little b, so that's b over there, and little c, and this is capital C. So, again, this information is what's required. So side, side, and the angle between. So let's say I gave you side C, side B, and the angle between them is A. And so that's side, angle, side. Two sides, A, or B and C, and then the angle between. So would everybody agree that the law of cosines would be the way to go? Because can't use the law of sines. So the law of sines, we only have one angle, so to use the law of sines would be the sine of little a is to A as, let's say, the sine of little b is equal to capital B as the sine of little c is to capital C. That's the law of sines. Well, it's okay to have this and not know A, because that's what we're solving for. But in this thing, we don't know this and we don't know this. So we're stuck, right? So you must use the law of cosines to get started. So what would be appropriate, what would a good one be here? In this case, we got side B and C, so we want to find another angle. So let's say we know B and C. We're given B and C and A. Yeah, so we would do A squared is equal to B squared plus C squared minus 2BC cosine of A, right? Because we know B, we know C, and capital C, and we know BC, and we need the cosine of A, right? So we could easily find A.
So, could you like also at this point use one of the other two to find one of the angles, and then use the sine, the law of sines from there?
Well, let's see, can you? No, because the other two, you need B, which we don't have.
I'm saying like to solve for an angle, but I guess because you don't have the side A, that you can't do that?
What do you mean?
Like
For
you
this
need-
triangle,
Yes.
with what information is given?
Right, but I was saying.
What angle could you solve for?
Well, weren't we just doing before where you could use the law of cosines to solve for the angles B and C and A?
Yeah, but from the previous?
Because that was side, side, side.
Right, this
Okay.
is side angle side. And we don't know, remember, the only angle given was A, right? So to use this equation, we need the angle little b, which we don't have. To use this equation, we need the little angle c, which we don't have. So we can't do anything with those two right out of the gate. So we need to use this one, and this would give us side A, if we do that computation. So now we would find this. So now we know this. Now we can solve for the other angles using the law of cosines, or the law of sines. Because if we went sine of little a is the capital A, as the sine of little b is capital B, we're able to solve for that now, right? So, but if we, what information was given? Information given was B and C, and we computed A. So, I guess it's 6 of one, half dozen of the other. I mean, you could try to make use of the information given as much as possible. So we were given B and C, and we computed A. Here, this is what we computed, and we were given that. So it really doesn't matter which one you want to do. Is that okay with everybody? That you're just gonna have to, the general idea is that you wanna use the information given as often as you can. But, I mean, eventually in some of these problems, you have no choice but to start using some of the computed values that you get. So that's side angle side. So now we down to angle side, I guess. So that's this situation. So now, let's just go back to this for a second. When we started this discussion, I told you that there's a situation where the sine of 180 minus theta, you can get an acute angle or you can get an obtuse angle. So when you use the law of sines here, you don't have to worry about that, because now that you know these three sides, so the triangle is formed in that case. So whatever the dimensions of the sides are will dictate the measurement of the angles. So you don't have to worry about that right here. So now we've got this, A, B, C. This is A, this is B, this is C. So now we got angle side. So if I give you A and C, if I give you A, I give you CB, so then I'm gonna give you either A or B, so let's say this guy. Is that right? So what would you do here? So this is given, this is given, and this is not given. So here you would use the law of signs, right? So you would do the sign of B, the little b, is to capital B as the sign of we're trying to find the sign of little a is, and from that you would find B. B is equal to what? A sine little b divided by the sine. So this gives us then B. And then we could find a C, which is sine well, C is simply 180 minus A plus B. So we know C. So here then the sign of little c is to capital C as the sign of little a is to N. So notice I'm making use of the information that's given to us as much as possible. And then, so this then is, what am I supposed to say? C, capital C, is equal to A sine little c over sine. So that's what that is, that's what this is, that's what this is, and we've got our triangle. Okay. So now, that brings us to the last type, and that is side-side angle. Side-side angle is the case where you're going to have potentially no solution, one solution, or two solutions. And that's, all these other cases you don't have to worry about in this situation. It is the side-side angle case that presents these challenges, and that, like I say, gives you 0, no solution, one solution, or two solutions. And the two solutions comes from the fact that, like I started class with, is that you take the arc sine, inverse sine of an angle, it's always going to return to you the acute angle. It's always, when you do your calculator, it's always going to return to you the acute angle. And then you need to consider that there's also the corresponding obtuse angle because of the relationship of sine of 180 minus theta is equal to theta, sine theta. So that's the one we need to talk about. The rest of these, we went through some examples. What time is this? This is period 2, right? 10:30, so we only got like a minute. So let's stop. We'll do that Monday and then do some homework.